again I'm with you and then covering a topic called binary search. Binary search is another method of searching a record, like we have already done linear search before. But whatever searching method you use, you have to have prior knowledge of arrays and functions of the procedures, because we'll be using all these things collectively in the program of binary search. So, but don't worry, I'll teach you from the basics, and then we'll start with the array first, and we're going to start this thing step by step. I'm using MU editor for Python programming. So let's dive in. I'm creating the main procedure called main, and then we'll specify the number of items, keeping 6 here, and then creating an array, a list of pre-stored numbers. But when you talk about binary search, make sure that array or the list that you have has to be pre-sorted in ascending order. So I'm sorting the data and writing data in a sorted form so that we can move on to binary search gradually. So the point to be noted here is the list has to be sorted. I've created a list here. Oops, there was a problem. A comma should be there. And then what if you want to produce an output, whatever is stored in the list? What if you want to show the contents of the array? So we can make a program directly for that, but I'll go in the detail of the procedure also. So we're going to design a procedure here, def, another procedure, def, and I'll say output array list. And then we can say for item in array list, print item. So I'll explain you this method, what this procedure will do. We need to call this here to produce output. So I'll write output, and then we'll say array and then we'll specify the list. I made a small program and then calling this procedure main. We'll have to take care of this indentation also and running it. So it says array is not defined. It was array list. Yeah. Array has been listed here. All the contents are there. List has been produced. How this particular thing is working. Let's have a look here. Over here, your program would begin from this line because I'm calling main first. So this one is the procedure number one, and that's the boundary of the procedure, starting with the word def, ending here. And we have another function there called main. How do you know which one is the procedure and which one is the function? So they both are the procedures. They both are the procedure. If there is a thing called return in the end, then we can say it is a function. This one is procedure one and procedure two. I'll give you example of the function as well. So when I'm saying main, so that means this main program will run. Number of item equals to 6. That means altogether there are 6 elements stored in it in the list, and all these are stored like that. List is sorted, and then I'm saying output list. What does it mean? That means I'm calling this procedure list and carrying the list also. Carrying the list also. What do you mean by that? That means whatever contents are stored here in the list, that will also be transferred, and then all are going to be transferred and stored in a new array parameter. It's called a parameter array list. So all these numbers are to be stored in it. So actually, we are transposing one array to another array that is defined as a parameter of inside this procedure of output. And then we are saying for item. Now, this word item is not necessary, is not essential. You can use any variable you like, X, Y, Z, whatever you want. But it becomes meaningful when you use the word item. So for item in array list, meaning whatever number of items, meaning the values, are stored in it. So this loop will run accordingly, and it's going to print all the item one by one. So it's going to show you 5, then 6, then 17, then 15, then 93, and then 128. So this is what is happening in this small program. So let's run it and check. So there you go. All the all the contents of the array list has been transposed and displayed properly. Now, moving on to the topic called binary search. In the binary search, how does it work? Let me remove these annotations. We'll be we're using an array, the list, and in that list there are multiple values like 5, and then we have 6, another number, then we have 17, another number, and then we have 54, 93, and 128. The array always begin with an index number 0, and it goes like that: 0, 1, 2, 3, 4, and 5. So last element is stored at the index of 5. How the binary search would work? Imagine that you have this array. So we're going to take out the mid value. The top is starting from 0, and then we'll say the bottom is at number 5. So we're going to add these two. Answer is going to be 5. And then we'll divide it by 2. We'll divide it by 2. So your answer is going to be 2.5. And we'll convert this into an integer form because we wanted an integer answer. So it's going to produce output 2. And in Python, if you want integer division to be done, so we always use double slash there. So that means this particular location has been chosen. Number that you are searching, you have to enter that number first. For example, you are searching 54. This is the number to be searched in the list. So we'll input this number, and now what will happen is this number that you want to search is to be compared with the middle element. It's to be compared with this. Is 17 and 54 equal? No, they are not. Then we'll see, is it smaller or bigger? If the number is smaller, so that means you have taken out the middle value where you saw the number 17, right? Number that we are searching is 54. So 54 must be located after that. So that means if the number is smaller that you are searching, so that means upper area is to be searched. And number, if it is bigger than the middle item, then we need to look at the bottom area of the list. So there are two possibilities. It depends what are you searching. If I'm searching the number 2, suppose, We are standing where? We are standing at the number 17. That means 2 in the list will be found where? In the upper area. And what if you are searching 54? If you're searching 54, so 54 must be somewhere down there. So there are two possibilities. Either you search in the upper area or you search in the lower area. But in both the cases, some changes are needed. This position is called the top position. The last position is called the bottom position. Bottom was always in the beginning, bottom is always at the last position here. But if we are searching 2, so what we'll do is we'll update this bottom. And how are you going to do that? Mid value minus 1. Mid value minus 1. This was the mid value where the 17 was located. So mid value minus 1 will give you, will update this bottom. And what if you're searching 54? In that case, your bottom will remain as it is here. In that case, you have to update the stop. And how will you update the stop? Uh, you'll have to add 1 in the middle value. If you're standing at the middle position, so you just do plus 1 so that the stop can be updated. And then this will be your targeted list. So this can be your targeted list now. So 54 must be located somewhere here. So in that case, what we'll do is, again, we'll take out the middle value. But how are you going to do that? Last time we did what? We updated the top, middle plus 1. So that means middle was 2. Now this number was 2. So that means top must have been updated. Mid plus 1 meaning top must be located at position number 3 now. And bottom is at position number 5 now. So once again, you'll do the same thing, that 3 plus 5. These positions are added and we're going to divide them by the number 2 to take out the middle value. And this way you can take out the middle value of this small list. So after making the first comparison, the half of the list has been cut down completely and you're left with this list only. So it is so fast. This binary search is so fast that you can, keep on taking out middle value and compare the middle number with the desired number that you are looking for. And every time you make the comparison, half of the list is to be cut down. I'll give you another example of this. Imagine that we have this list and data that I'm finding is find what, find what, or search what. This is called find what, or you can say search what, or you can say sort data. Different names can be given to it. Supposingly, I want to search 54. So what were the steps that I told you? That index is starting from 0, 1, 2, 3, goes like that. I said that we'll use a formula and we'll find out middle value. And how would you find that out? We'll say the first number, the first address is 0. The last address is 5. So what we do is we can add them up. So the total is 5. And then we can divide this total by 2 and we'll calculate the integer answer also. We'll convert this into integer so that we won't have any decimal places. So that means this is called middle value. Middle value has been taken out. So the middle value is 2. That means you are standing where? You are standing at position number 2. That's the middle value. And at this middle position, what do we have? We have the number, we have the data, 17 is stored here. Let me clarify here that this column is for the index. Indexes are automatically created with an array. This column is for the data, the numbers that are stored in it. So now what we do is we can compare the number. This number 15 is to be compared with the middle item. Is 17 and 54 same, identical or not? Is 17 and 54 are same, identical or not? That's what we are looking for. So we'll say no, 54 is bigger, 17 is smaller. So that means the list is already sorted. So all these numbers, that means 54 will not be located here. So this list can be discarded. Half of the list can be discarded right after the first comparison. In that case, your first that was there at the zero location, we need to bring it down after this middle position. Now the first element of this remaining part of the list is 3. The first should come down. How will you bring it down using your program? So you can do middle value plus 1. Middle value plus 1 will do what? This will bring this first pointer down. And then now we'll recalculate the middle value. The first is 3 now. Last is 5. And then the middle value is now 4. Middle value is now 4. So that means this time we're going to make the comparison of this 54 with this number stored at the middle location, 93. 93 and 54 are to be compared. Are these equal? No, they are not. If it is equal, so you can say, yeah, item found at middle position. But now, as the number are not equal, so we'll have to see that your desired number is 54. 54 is smaller than the number stored at the middle position, meaning 54 is smaller than 94. So you're not going to look further down. So you'll have to search in the upper area. So in that case, what we're going to do is half of the list is to be cut down completely, including that middle location. In that case, we'll recalculate the middle value. Now we're left with one item only. So first is 3. The last will also be 3. We need to update this last. And how will you update this last? We'll say middle minus 1. So bring that last here. And you can say 3 and 3 and divided by 2. Total is to be divided by 2. That means the middle location is 3 now. So middle location is 3. And that is the location where your desired number is located. This is how the binary search is done. So after 3 comparison, you get to your desired element easily, right? So my dear student, I hope you must have understood this, that this process should go on. So if I give you a precise view again, if the list is big enough, it doesn't matter whether you have array of numbers or array of letters or words, starting with the zero element going up till 999, 999 elements are stored there. First you take out the middle value. First you take out the middle value, mark the midpoint, and then compare the number stored here with the number that you wanted. What if I wanted the number 2? I said, and then middle position, at the middle position we have the number, say 339. So this number is not the one we are looking for. So that means we'll have to look in the upper area. So half of the list is to be cut down. That means this part of the list is to be eliminated completely. And what can be the other scenario? The other scenario is, what if the middle position number is 339 and you are searching 749? So you're not going to find this number in the upper area. Why? Because list is already sorted. So this part of the list, including the middle element, is to be eliminated completely. And this would become your targeted list. So in that case, your bottom will remain, the last pointer will remain as it is where it was. You have to bring that top down. So top is going to come here. And how would you bring it down? So mid value plus 1, mid value plus 1. So remember the two things, the 2 pointers plays a vital role here. After making the comparison with the middle item, you're going to decide whether you have to search in the upper area or in the lower area. Number you are searching is 33, suppose. You're standing at the middle position. That is the middle position. If that number is found here, so that means job can be completed. Otherwise, there can be two things, two options. Either you search in the upper area or you search in the lower area. So when you search in the upper area, the top will remain as it is here, and the bottom would come up here. And how will you bring this bottom here? So you can say bottom equals to mid value minus 1. And how will you bring the top down here? Just in case if this is your target area, for example, in that case, the bottom will remain as it is where it was. You're not going to touch that. The bottom will remain here. In that case, you just have to move the top down. The top would come here. And how will you bring the top down? So you'll say mid value plus 1 to be stored in the top. Now, let's come to the point. In binary search, what kind of programming is needed? So I'll have to make a function here, and then I'll write down the function first, and then we'll call it later on def binary search list, comma, search item. So I'm giving it two things: item that I want to search plus the name of the array, the list. And then additional pointer variables are needed. So I'll say first, examiner can call it first, can call it top, last, examiner can call it last, can call it bottom, can be equivalent to 0. It happens in Python that one number can be stored in two variables. So if I'm writing first comma last equals to 0, that means I'm moving 0 in both the variables, comma, and then calculating the length of the list. Length of the list minus 1. Why am I doing minus 1? Because the index starts from 0. For example, if you have 6 items, so in an array, when you store those 6 items, it will go from index number 0 to 5. So n minus 1, right? So after that, we'll come up here, and then a couple of more variables needed. So I'll say found. Purpose of this variable found is whenever the item is found, so this will become true. And then you can say search field. There can be a possibility that search might be failed. So I'm going to put this false in the first variable. The second false is to be stored in the second variable in the sequence, like that. So initially, when your program would begin, we are not sure whether item is there or search has failed. So initially, we'll start with false, false. That means we're not sure, and then we'll proceed further. While not found. So that means this loop of while should be continued until your desired item or the number is found. And search and not search failed. So that means your program should keep on running if the search has not failed also. Now we are working inside the while loop. Indentation is important. You need to keep an eye that when I press enter here, we're going to put a colon and press enter here. The cursor is automatically shifted slightly to the right. And then we'll have to calculate middle item. Middle equals to, let's say, first plus last, and then divide using double slash sign. Why? Because I want to convert the result in integer form. And then middle value has been calculated. Now we'll look at this middle position. We're going to write a square bracket for the array. So that means I'm saying go to the list, go to the middle location and check. So we use double equal sign to make the comparison, and we are comparing it with the search item. Search item is the number that we are looking for. This will come from here, search item. And then if it is equal, that means found is equals to true. What does this mean? That means you have a huge array, big array. You have taken out middle location. You have taken out middle value. At the middle position, you have a number, suppose 34. And imagine that 34 was the number that you were looking for. So you took out the middle value and then you compare it with the middle value uh, number. So 34 and 34, they both are equal. So says, our program says, if it is equal, that means what? That means found is equals to true. That means found is equals to true. Why? Because you found your desired item there. But what if the number that you're looking for is 2, and this was the number called search item. This was the number called search item. Then what will happen? So we'll see. We'll see. So I'll go back to my program. I've explained you this. Moving to the next part of it, and then we're going to write else colon. After that, we'll see if first is more than equals to last. That means search field is equals to true. This means what? That means this means you have nothing in the list. You have nothing in the list. Standing at the first position. And first is bigger than the last. Last is, behind that first. So in that case, your search is going to be failed. After that, moving to more conditions that we need to add in our program. Here I'm going to write else colon what? Else if the first, the list of middle item is more than the search item, then what? Then last is equals to middle minus 1. Let me explain you this part now. Keep an eye on the sneaf command that we have written. I'm writing if list of middle item, that means this item, is more than the search item. This is what we wanted to search. So in other words, I'm saying that 34 is 34 bigger than 2? Yeah, it is. In that case, what? In that case, lost should be updated. So loss should be updated how? Loss should be updated like middle minus 1. This is what we are doing in that case. Middle value minus 1. Top will remain as it is. But that means this will become your target area. This will become your target area. And then the half of the list is to be cut down. And once again, you repeat that whole process, find out the mid value, and then you make the comparison. If you find your data at the middle position, task can be completed. Otherwise, maybe you'll search in the upper area or search in the lower area. So this will be your targeted list. In that case, you take out the mid value and then you can search either in the upper area or in the lower area, depending upon the value you're searching. So I hope you must have understood this if command that I've written. Now, expanding it further, and saying else colon first is equals to, otherwise first is equals to middle plus 1. What does it mean? Now look at this. At the middle position, you have the number 34. Imagine the search item can be any number, will be your choice. You might be searching 2, you might be searching 90. So if we talk about list of middle meaning 34 is more than, what if you're searching this number 2? 34 is bigger than 2? Yeah, it is. In that case, this part will run. That means this will become your target area. But what if you're searching 90? So in that case, your search item is going to be 90 and middle item is 34. And we're saying 34 is more than 90. No, it's not. So that means then part will not run. It will jump onto the else part. In that else part, we are saying what? We're saying the first should be updated and first should become what? First should become middle plus 1. So that means you're not going to touch the last. The last pointer will remain as it is there. And you just have to move this first and bring it down. And this is how you're going to bring it down. And in the end, when the if command will end, these were nested if command. When all these if command will run, cursor will come out and this while loop will end. Why? Because I'm writing on the same line. So that means out of the loop, not inside the loop. And out of the loop, I'm saying return. It should take back what? Should take back whether the data found or not, meaning it will take true in it. Whenever the item is found, this condition will get true and then found would become true. And that's what I wanted to return. And then with that, I want to return the middle position also so that we can produce output and say where that item was located. So item must be located at the middle position because every time we make the comparison with the middle element, so that's the position where the number is stored that you're looking for. Now, we have made the program for output. We have made a function. This is the first one. The output is the procedure. Why? Because it doesn't have return in it in the end. Over here, we have written in the end. So that is why we say it is a function. Function always have this loss statement return in it. And return meaning that you're going back with the results. Now we just need to call this here, but before that, we'll have to tell the computer what number you're searching. So inside the main program, we need to add a couple of more lines here. Over here, we're gonna write search item, and this will be equivalent to what? Integer, and then you input the number, enter number to search. Whatever number you write there will be converted to an integer if you write in point form, converted to an integer. And then we are saying store it where? Store it in the variable search item. So it will prompt you, enter the number to search, and that number is to be converted into integer and then will take place in the variable search item. After that, we're saying the variable found, the variable position equivalent to binary search. In the binary search list, comma, search item. Now this means what? Let me explain you this part. It says binary search. That means I'm calling this binary search function. So this will jump there. And it would carry two things with it. It would carry list and the search item. And this will take place in this parameter here. And this would take place in this parameter here. And I already have explained you this part. So you know this is stuff. But why two variables are written on the left here, found in position? Because when this function will run and it would end, this function will return two things. The found, so result of this found will come here, and result of this middle will come here. That will be the position where the number is found. So these are the two things. I want the results to be stored in these two variables. The found should say true, and position should have the location, the middle location stored in it. After that, we'll have to say if found colon, we can say print F is for the formatted result in Python. And you can say found at what? Found at the position number where the position is stored. That position is stored in this variable position. So when you want result of that variable, you are writing variable, so it has to be enclosed in these curly brackets. It is the text. Whenever you are writing text with that inside the quotation mark, you're writing text and the variable both. So make sure that you write down the variable in curly brackets. And remember, that's going to give you a position starting from 0. So started from 0 location. And then we're going to close bracket for the sprint. And after that, we can say, what if not found? Else, in that case, it should say print item was not there. That means the data was not there that you were looking for. And then calling this main. So I run it. It says enter the number to search. Enter the number to search. You're writing 17. Enter the value to search. And you're writing 17. So it says found at position number 2. Started from 0 location. So we made a program for output to produce the contents of the entire array. We made a program for the binary search. This was a small function. And then there was a main procedure where we are calling both the procedures and we are entering the data to search. And after that, we're calling binary search. And then we're calling output procedure also. So I hope that you must have learned how binary search works. Just the last thing for this binary search. Binary search is recommended when you have huge amount of data. Otherwise, this kind of long program can be waste of time for a small list of data. What if you have 5, 6 items? So you can, use linear search method, the older method that we used before. Binary search is always recommended for a huge list of items. There's one thing called big O notation. In the past paper, 1 mark question, 2 mark question always comes. You just have to write down this formula when the question comes. Write down the big O notation for binary search. So that is the big O notation. O is an indication of big O notation. Log 2n is the formula that tells you about the complexity involved in it. So binary search does what? The total time, this big O notation tells you what? It tells you the total time taken increases as the data size increases. So if you have a small list, it will take less time. If you have a large list, obviously it will be keep on taking middle values. So it would take time. Each comparison halves the data set. So we always make the comparison with the middle value. And then after the comparison, your list is going to be divided. One part of the list is to be discarded. The other one is to be used. Maybe upper area or maybe the lower area. So the time taken increases by smaller amounts and approaches constant time. So remember that it is not recommended for small list, recommended for the large list. Here we're using log base 2, log 2n, and then x. What is that x and log 2x is what? I made it simpler for you here. That means how many times do we need to multiply? How many times do we need to multiply a number by 2 to get the number x? Example, if you're talking about log 2 4, so that means how many times will you multiply 2 to get 4? So you can say you multiply 2 times to get 4. Similarly, log 2 8 meaning what? How many times you would multiply the number 2 to get answer 8? So that means 3 times. So that means after 3 comparison, you can get to the desired data list item that you have there. So for the big O notation, you just have to memorize the formula, and these details are not required, but this part is important. for big notation of the binary search. So, guys, take good care of yourself. This was the end of the lecture of binary search. So, I hope you have enjoyed this session and you must have understood. Thank you very much. Take care.